Hello everyone. Today we will discuss about magnetic field and its related phenomena and its different points. Magnetic field is very similar to gravitational field and electric field that we studied previously. Basically, magnetic field is produced by a permanent magnet. There are two ways in which a magnetic field can be produced: a permanent magnet and an electric current. Yes, definitely electric current can produce magnetic field. We have a permanent magnet. It has two poles. First one is north pole and the second one is south pole. And just like positive charges and negative charges, in fact, electric fields originate at a positive charge and terminate at a negative charge. In a similar manner, the magnetic field lines originate from the north pole and terminate at the south pole of the magnet. A single charge can exist, but a monopole cannot exist. This thing you should keep in mind: monopole cannot exist. What does it mean? It means if you split this permanent magnet, this again will split into two separate poles, north and south, and again north and south. If we keep on breaking this magnet and continue, it will create again, it will keep on creating more north and south poles inside. So monopole cannot exist. A single north or a single south pole cannot exist. So if two magnets come close to each other, the north and south will attract each other. We can say that similar poles will repel each other and opposite poles will attract each other. Like north will attract south and south will repel south. They will repel each other in a very similar way when two charges repel each other. And of course, opposite charges attract each other. So moving on to the next point, in this way here, you can see that two like poles repel each other. Their magnetic field line go outward, and this is a zero field location, zero field region. There will be no magnetic field in this region because magnetic field lines are repelling each other here. Okay, this was all about the permanent magnet. Now you can see that if we have a conductor, like here is a conductor in which electric current is flowing upwards. Electric current is flowing upwards. So we can see that the magnetic field will be generated in a circular shape here. This will be magnetic field created by the electric current. So this will be the magnetic field. So just keep one thing in your mind. The magnetic field is generated by moving charges. Either it is a conductor or it is a permanent magnet. Yes, a magnetic field is generated in permanent magnets by moving electrons, by moving charges. It could be a coil, like a circular coil. In this way, the coil will be named a solenoid. This is the coil. If current flows through this coil, then magnetic field will also be generated like this. This will be north pole and this will be south pole. Okay, so this will be named as a solenoid. Basically, it is a circular coil in which magnetic field is generated. In the direction of the magnetic field can be found by your right-hand rule that we will discuss later. If we look through point A from this side, we will be looking at the current coming from the outside of the page. And for out of the page, we will use a dot. And if we're looking through B point, we are looking at the current coming from into the page. Then this will be symbolically shown by a cross. So the cross means that a magnetic field is moving inwards, and the dot showing that the magnetic field is moving outwards. Now we will talk about the direction of the magnetic field, to find out which we use the right hand rule. It says curl the fingers of your right hand in the direction of the current. In case of a solenoid, your fingers will tell the direction of the current. Your thumb will indicate the direction of the North Pole. This side will be North Pole and this will be South. So by curling your fingers of your right hand in the direction of the current. Now this was the case for a solenoid, also a case for a current carrying conductor. Like this, your thumb will indicate the direction of the current. This is the thumb, and the curl of your fingers will indicate the direction of the magnetic field.